Okay, as I've already told you, I am going to make one presentation on DK, DK by T, and definitely EOP, equivalent oxygen percentage. So let's move forward, and it's very important to you understand this concept to your bone. Okay, so let's move. So what is oxygen permeability? It means basically, so first thing, the important thing is oxygen permeability is an intrinsic material property. Just to be clear, it's the property of material itself, finished, intrinsic. Okay, so what it does op- one way you can say it allows oxygen to pass from that particular material, or at the same time you can say resist the gas flow, whatever. How it is defined is the rate of oxygen flow under a specific condition. Specific condition means its temperature, uh, and definitely in pressure, there are a lot of things under a specific condition through unit area of the contact lens material of unit thickness when subjected under the unit pressure difference. So basically means it's a flow of oxygen. Okay, rate of flow of oxygen. So under a specific condition, yes, a specific condition is thickness, and so not thickness particularly, but under pressure and under unit areas and so on. But what do we mean by oxygen permeability? Is rate of oxygen flow. So one of the famous thing about oxygen permeability in case of optometry students' life or examinations is this, the unit of oxygen permeability. Okay, so it's very useful whenever when you become practitioner or whatever, because when you become practitioner, then the most important thing when someone you asking about contact lens, and when someone uh, once you are trying to recommend contact lens, then definitely you see the decay or decavity of the material, so that you have idea that this material is not going to create hypoxia, isn't it? So that's why it's very important throughout your life, throughout the journey of optometrist. Okay, so permeability has a unit d into k. What do you mean by d into k? D is diffusion coefficient, k is solubility coefficient of oxygen in a given material. What do you mean by diffusion coefficient and solubility coefficient? So diffusion coefficient is defined as a velocity. Just remember this term. Okay, velocity of oxygen basically means movement. Diffusion means oxygen gas molecule moving into the lens material. So this is the lens material, and this is the oxygen molecule. It passes, it moves in a, and it crosses basically it crossed this whole material, isn't it? That's diffusion. Diffusion means velocity of oxygen molecule that passes the lens material. Okay, velocity is randomly moving gas molecule diffused through the material and expressed in terms of area per second. Why area per second? Because velocity we have learned meter per second or second per second, centimeter per second, sorry, centimeter per second. But whenever we are talking about gas molecule, especially oxygen, it passes not in a straight line, but whenever oxygen molecule in zigzag line. Okay, and it exits, so it covers area. That's why we take not centimeter per second, but centimeter square per second. Okay, this is the important concept. So that's the concept. Okay, so what is solubility coefficient? K means solubility coefficient. It basically means defines the volume of oxygen that can be dissolved in a contact lens material. Means in how it expressed in the term of volume of oxygen and volume of material, pressure derived by the oxygen into the through the material. Basically means the volume of how much mole of oxygen is dissolved in how much mole of contact lens material. And it is definitely a certain particular what do you call it, pressure, and at the particular temperature. Yes, there is thing, but it's very important that solubility coefficient means oxygen dissolved in that material. diffusion coefficient Diffusion coefficient means that dissolved oxygen moves from anterior surface to posterior surface, and that movement that diffusion is diffusion coefficient. Okay, diffusion coefficient means movement, so movement in area per second, and solubility coefficient means solubility of oxygen in solubility of material, mole of material at particular pressure mmHg. That's what the unit. That's the unit of d, and that's the unit of k, because decay unit is very important in terms of mcqs and to understand actually decay unit. Okay, it's very important. So decay varies directly in the temperature. It's another point, because with temperature solubility varies, with temperature diffusion varies. That's why it's directly varies with the temperature. So higher the temperature, greater the decay. It's always there. It's always there. Higher the temperature, greater the decay. So mostly calculation temperature around 34 degrees Celsius. Okay. So why? Because 34 degrees Celsius is approximately corneal temperature. Our body temperature is approximately 37 degrees Celsius, but cornea is cooler, around 3 degree cooler than the body, which is 33 degrees Celsius. That's why we measure decay around 34 degrees Celsius. Okay, so it's a calculated value and provide useful guides in clinical applications. And what it does allow the selection of stock design contact lens, which will provide the adequate supply of the cornea. So basically, decay of PMMA, polymethyl methacrylate, is zero. At the same time, decay of baraflucon, decay of what you called, I don't know. Baraflucon has a I think decay by T140, but roughly it's way up, isn't it? Yes, but clinically we use decay by T more often, not decay, but decay, yes, it's comparison of material. I'm not sure decay of paraflucon is 140 or something, but let's take an example. Okay, so the rough, then you can understand how much oxygen can balaflucon pass, isn't it? So that's how we compare. So oxygen permeability unit, I have already told you that unit is most important, because a lot of time MCQs came from unit. I have already told you centimeter is square. Why centimeter? Not centimeter, but centimeter is square. Okay, and mole of oxygen dissolved in mole of material at mmFH particular pressure. And common lens subscript is omitted. Basically means, and another point, oxygen permeability unit is always 10 to the power minus 11. Okay, whenever you see 10 to the power minus 9, it will be oxygen transmissibility, it will be decay by T, not decay. So decay is 10 to the power minus 11, and ranges in contact lens 0 to 300. I think 300 is in silicon elastomer, I think so. So permeability is influencing definitely water content in hydrogel contact lens, not in silicon hydrogel contact lens, and not in silicon hydrogel contact, not in silicon hydrogel contact lens, not in, definitely not in uh, RGBs. Yes, and chemistry of polymer. Yes, definitely. Method of water retention. Yes, temperature, pH, and tonicity, because tonicity directly affect the water content. So these are the things you must understand. These are the points. These are the points, and it's very important points whenever you are going to. We are going to face the examiner in your viva, because if they ask this question, then at least you can tell them 4 points, minimum 4 points. Okay, minimum 4 points. Tell them to examine, so which is very good. So now let's come to the oxygen transmissibility. Oxygen permeability is dk, and oxygen transmissibility is dk by t. So it's a particular lens under a specific condition defines the ability of lens to allow the oxygen to move from anterior to posterior. And in another term, oxygen transmissibility is oxygen permeability divided by thickness, isn't it? So value often may be geometrical thickness, or depending upon the transmissibility calculation, and not a physical property of contact lens material. So it's not an intrinsic property. Yes, decay is an intrinsic property, but decay by T, oxygen transmissibility, depends upon the characteristics of the thickness. Okay, so but it's a specific characteristic related to sample thickness. That's important. That's why it's not intrinsic property itself. it's it's different from one contact lens to another contact lens. It's different from plus contact lens to minus contact lens. Let's take an example of plus 10 contact lens. Let's take an example of minus 10 contact lens. What you will expect? In plus 10 contact lens, central thickness is higher. That's why decavity is lower in central, but at the same time higher in periphery, because peripheral thickness is lower in plus. But at the same time, minus, central thickness is thinner. At the same time, peripheral thickness is thicker. So that's why in peripheral contact lens periphery, decavity is lower. At the same time, contact lens center, decavity is higher in minus 10, isn't it? So that's the concept. It's very important. So exponent 10 to the power minus 9 is upon into unit of transmissibility because the thickness expressed in centimeter. Because see, we have already known centimeter is square divided by second into mole of oxygen dissolved in mole of material into mm of Hg. Now whole divided by centimeter. This centimeter will cancel this one, centimeter square. Now centimeter means minus 2, isn't it? So from 10 to the power minus 11, if you divide by 10 to the power minus 2, what you get? 10 to the power minus 9. That's why I have told you that 10 to the power minus 9 is a unit of oxygen transmissibility, not the unit of oxygen permeability, because oxygen permeability means 10 to the power minus 11. Okay, so that's the concept. And the example of thickness of 0.1 mm is 0.01 centimeter, and it's normally specified in the specific temperature of 34 degrees Celsius. Sometimes 34, yes. So again, D and K is diffusion coefficient and solubility coefficient. So the permeability and therefore transmissibility are temperature dependent and related directly, because temperature dependent means what? The only difference is T divided by T, isn't it? That is, the higher the temperature, higher the decay goes, and therefore higher the decay by T goes. Because in decay by T, the only difference is T, thickness of the contact lens, and we know that contact lenses are not uniformly thickness from center to periphery. For minus, periphery is thicker. For plus, center is thicker, isn't it? Yeah. So oxygen transmissibility, that's what I was telling. Why it's centimeter? Because we have divided 1 centimeter, because we have divided by T. Common length substitution is omitted. And just remember 10 to the power 9, when you see 10 to the power 9, it's oxygen transmissibility, not oxygen permeability. Okay. And unit, it's favorite question in MCQs. Okay, it's always favorite question. Unit. Just remember this point. So I've tried to discuss a few differences between decay and decavity. See, decay is inherent ability of lens material allows the oxygen to diffusion into solubility. At the same time, decavity is actual amount of oxygen passing through the lens specific thickness, because thickness is dependent specific contact lens. I have already told you about example of minus 10 and plus 10. So decay adjusted for thickness. That's it. In decay, basic means D is diffusion coefficient, K is solubility coefficient. Diffusion coefficient unit centimeter per second, solubility coefficient is per ml dissolved in per ml material at mmHg. At the same decay, T is another point when we divide decay by T, isn't it? Typical unit, yes, decay is called bearer, not decavity. Okay, bearer or fat unit. 10 to the power minus 11, I have already told you. 10 to the power minus 9, I have already told you. And in case of decay by T, bearer divided by centimeter. Dependent on the thickness, decay is not dependent on thickness, not at all. So that's why intrinsic property we have called, yes, decay by T is also intrinsic, but at the same time, T matters, and T is not an intrinsic property of a material. T is a property of a contact lens, a specific contact lens of a specific power, inversely proportional to the thickness. Thicker the lens, smaller the decay. Even at the same lens, if it's thicker at the center, decay is lower. If it is thicker at the periphery, decay is lower at the periphery. So clinical relevance, useful comparison, material oxygen capacity. So we always compare one material to another, not particular contact lens. So clinical relevance, more relevance to predict oxygen availability cornea, risks of hypoxia, etc. And even it is more reliable that we try to predict oxygen passes to central cornea and peripheral cornea whenever we have high amount of if refractive error, like let's say minus 10 or plus 10. So let's move to another topic that we're going to discuss. So this is just a simple thing that low oxygen transmission can result in, we have already discussed this, microcyst polymaganetism, corneal pH increases, corneal edema, platelets transient response. We will not going to touch it today. So I have taken this from CT article just to show you dk and dk by t at 3 diopter minus 3 diopter material at center. Water content, see, in all material etaphilicon 2833 dk and dk by t. So nasophilican 42 42, nanophilican 26, and these all things, see. So which is nanophilican, philophilicon, centiphilicon, this all material has, you see, galliphilicon, xenophilican, dk and dk by t. Okay, that's important. It's thickness, isn't it? Yes. So you can go to and water content. So you can go to this article and go just read this graph or understand this graph, which is better. So what is equivalent oxygen percentage? It's very important. So oxygen concentration of gas mixture, nitrogen, water vapor that produce corneal response equivalent to that resulting from the wearing of contact lens. See, whenever we wear contact lens, basically, if let's take an example, if there is a 21% of oxygen in the atmosphere, whenever we wear contact lens, that oxygen will definitely go down at exactly at corneal surface, isn't it? Because of contact lens basically hinders the oxygen passes. Let's take an example, 15% of oxygen came to corneal surface. Then what happened? Because of this hypoxia, there is response, isn't it? Physical response. So the oxygen pressure in the air concerned about 21%, which is equivalent to 155 roughly, isn't it? So quantities of corneal environment under contact lens ascertaining what oxygen concentration produce an identical corneal response to that product by the lens basically means there is a corneal response and what concentration of oxygen will create that response, so that we come to know that this is the equivalent oxygen pressure or oxygen percentage. So equivalent oxygen percentage aims to offer the percentage of concentrated oxygen that may pass through the lens to anterior cornea, and if we reduce it, there is a response, and we can say that yes, this response comes at this level of equivalent oxygen percentage. For example, if available oxygen from atmosphere in the transmitted by the contact lens to the cornea, then the lens would have EOP of 29%, which is equivalent oxygen. If all the available oxygen can be passed, but it's not happen, is it? No, not at all. That's why it always contact lens always reduces the equivalent oxygen percentage. So so in vivo measurement made on the living tissue and therefore provides a more accurate indication of corneal function. Another is the result of corneal oxygen consumption measurement provide the accurate indication of oxygen needed or thrust of the cornea. Any type of lens can be fitted and assessed made on the effect of corneal oxygen consumption rate. So permit direct comparison of soft contact lens and RGB contact lens. Basically means what are the changes there's we have seen in the cornea, which is basically how much oxygen percentage is dependent. Basically, see, if more less than 15% oxygen is passes, then we hypoxic condition creates. But let's take example. Let's say less than 8% of oxygen, equivalent oxygen is there, and then it will create reduction of sensitivity. Let's take example. So this is how we see. Okay. So equivalent oxygen percent defined is the estimation of oxygen concentration at the corneal surface under contact lens express the percentage atmospheric. So basically means if naked eye it's always 21%, but under contact lens it will reduce the passes of the percentage of oxygen, and we will examine according to. So origin, it defines the experimentally by comparing corneal swelling without the lens, okay, and with matching the oxygen tension from that history, the equivalent oxygen percentage derived. Why it matters? Because Equivalent oxygen percentage reflects the real physiological oxygen availability to the cornea more directly than decay and decay by T, because it incorporates thickness, fit, tear exchange, and actual corneal response. See, actual corneal response is central important, but we are going to take all things account in case of equivalent oxygen thickness, fit, tear exchange, because all things will carry oxygen to corneal surface, isn't it? So relationship to decay, yes, obviously, if decay by T goes higher, then higher the EOP. But EOP gives clinical meaningful oxygen filled by cornea rather than just material property. So EOP means equivalent oxygen is clinically if there is any sign or symptoms. Is there a prominent corneal nerve? Is there striae or is there a fold? Then we will know this kind of equivalent oxygen percentage will create fold, isn't it? But decay by T will not give that. So interpretation guide is approximately 21% is always normal. It's open eye condition. Below less than 10% is always now it's red alarm. It means hypoxic stress. So definitely modern silicone elastomer open eye condition reach good amount of oxygen, which is 15 to 18%. Okay, so obviously it's more than traditional older hydrogel contact lenses. So let's discuss this slide. Okay, this I think this is the last slide. So difference between decay and EOP. So definition of decay is intrinsic property of material, but at the same time definition of EOP is physiological estimation, effective oxygen concentration at the cornea under lens based on corneal swelling. So why EOP is derived based on corneal swelling? So based on examination by historically to examine what equivalent percentage will create what kind of swelling. That was the history. But now we use in many other things. So what is measures? Decay measures diffusion into solubility. We have already discussed about it. But what EOP measures is percentage of oxygen equivalent to what cornea feels under the contact lens. Basically means if from 21 we reduce to 10%, what cornea feels. Swelling, yes. Sensitivity reduction, approximately. Not that, but yes. And there are a lot of things. Prominent corneal nerve, yes. So there are a lot of things. These are the things that cornea feels, isn't it? So formula D into K, we know it. No direct formula derived experimentally by matching corneal swelling with and without lenses. Yes, unit 10 to the power minus 11, I have already told you. Centimeter square, I have already told you. But unit is oxygen percentage atmospheric oxygen reached to the cornea. That's central important. Scope describe only the material property independent of the thickness. At the same time, EOP describe corneal response taking thickness, fit, tear exchange all into account because these all things will help to pass oxygen from atmosphere to the corneal surface, isn't it? Clinical relevance used to compare material input calculation by decay. At the same time, more direct indicates risks of hypoxia and swelling in real life. EOP. Limitation does not reflect the actual oxygen reaching the cornea once the lens is made or fit. At the same time, limitation indirect, not routinely available for lens. Is it? It's not routinely available for every lens. It's not possible. EOP. So relationship higher the decay usually leads to higher the decay by T and thus higher the EOP, which is very important as a clinician, as a student you have to understand. The higher the EOP usually means higher the oxygen delivery. So but EOP depends on decay and other factors. Yes, definitely. These are all interconnected, isn't it? Yes. Okay, the one thing you do not take a unit from this point, okay? You take unit from another previous slides, previous um, point in the videos. Okay, I think that's it. I think I have finished now. Okay, so bis dann, tschüss.